There is a kind of stillness that is not the absence of motion, but the presence of balance. You rest within it now. It is not the stillness of silence, because even here, far from the nearest star, there is a hum, a slow vibration that seems to come from everywhere at once. It is the pulse of the cosmos. You have always lived inside it, though you have rarely felt it. Your life has been too quick, your days too short, your thoughts too crowded. The universe does not beat to the rhythm of human hearts or the ticking of clocks. It moves to something slower, older, a time so vast that you cannot measure it, only sense it. If you could place your awareness against the fabric of the universe, as one might place an ear to the earth, you would feel the faintest tremor, not the rapid tremor of instability, but the deep, steady throb of something enormous and alive. It is not a heartbeat in the way a heart pumps blood. There is no muscle here, no chamber, no flesh. It is the rhythm of expansion and gravity, of matter drifting and being drawn back, of galaxies swaying in invisible tides. This slow pulse is older than any star. It began not long after the universe was born, in the moment the first light broke through the darkness. Space itself began stretching then, and it has never stopped. Yet that stretching is not smooth. It is like breathing, not in and out, as we know it, but a vast glacial inhalation that carries all of creation with it. You drift inside that breath. Galaxies are not scattered randomly. They move together in streams and clusters, drawn into great walls and woven into a cosmic web. Between those threads lie deep voids, enormous spaces where almost nothing exists. And yet, even the emptiest void is not truly empty. Space itself swells and shifts, carrying with it the whisper of that universal beat. If you could slow time down far enough, you would see it more clearly. Galaxies like dust motes, suspended in a current. They drift toward one another, swirl, and sometimes merge. Around them, space continues its long expansion, like a tide that never recedes. The pull of gravity tries to gather them. The stretch of space tries to separate them. To forces in constant conversation, it is this conversation that makes the pulse. Somewhere in the darkness, a wave of density moves through the fabric of space, a ripple left from the earliest moments, when matter was young and hot. Those ripples are still here, though stretched now to the size of hundreds of millions of light years. They guide the galaxies like hidden channels in a great river. You cannot see them, but you can trace their effect in the shapes of the largest structures ever to exist. This is what it means for the universe to have a heartbeat. Not a rhythm we can hear, but a pattern we can feel in its architecture. It is the slow rising and falling of the largest scales of matter, the quiet swelling of space itself, and you are part of it. Your atoms are carried in that same tide. Every particle of your body rides the same expansion as the most distant galaxies. The calcium in your bones, the oxygen in your lungs, the iron in your blood, all of it drifts, ever so slightly, in the same universal swell when you breathe. In you echo the cosmos. Perhaps that is why there is a comfort in slowing your breath, in letting your chest rise and fall without effort. It is a kind of agreement with the large emotion. You do not need to rush. The universe does not hurry, and neither must you. The pulse is not uniform everywhere. In the densest regions, in the cores of galaxy clusters, gravity dominates. Here, the beat is more like the slow circulation of a great ocean, swirling and folding back on itself. In the vast voids, the expansion is freer, faster, like wind over an open plain. And yet, the whole remains connected. the rhythm preserved over billions of years. This rhythm has ridden the architecture of everything. It has determined where galaxies form, how stars are born, and where the great dark spaces between them will remain. Even now, it is still shaping the future, though so slowly that only the patient eyes of the cosmos can see the change. You think about time differently. Here, a second, a minute, an hour, these are measures for small things, for human lives and human concerns. But the pulse of the cosmos measures in hundreds of millions of years. One beat may last longer than the age of your entire species. What, then, does it mean to say that something is soon in the language of the universe? Soon may be 1 billion years, and yet, for the universe, that is hardly any time at all. This changes how you think about beginnings and endings. If the pulse has been there since the dawn of time, and will continue long after your life ends, then you are not separate from it. You are simply one brief note in its endless rhythm. And yet, being part of that rhythm means you carry its story. The atoms that now rest in your hands were once part of ancient stars, which themselves were gathered by the pulse into the places where they could form. Without that slow, patient beat, there would be no stars, no planets, no life at all. It is easy to think of the universe as a silent, indifferent place. But here, in the stillness, you can feel its constancy. It does not rush. It does not panic. It simply continues, as it always has, breathing its vast breath across the ages. You wonder what it would mean if that pulse ever changed. What if the expansion slowed and stopped? What if gravity began to pull everything back, reversing the flow, drawing galaxies together again? What would that sound like in the language of spacetime? A slowing heart, or the deep inhale before an even greater breath? For now, there is no sign of such a change. The expansion continues, steady and unhurried. But the thought lingers, like the awareness of your own heartbeat, unnoticed most of the time, until something makes you listen. The universe is old, but it is not finished. The pulse you feel now is only one part of its long life. There have been other rhythms, faster, hotter, more chaotic, and there will be new ones yet to come. You let yourself drift in this one, in the darkness. The galaxies do not speak, but they move together in the great tide. You are carried with them, without choice, without effort. The beat is slow, but it is sure, and it will carry you for as long as you exist. You close your eyes, though they were already closed, in the way that dreams close them, and feel the pulse again, slow, steady, patient, the same as it has been for billions of years. Somewhere far ahead, a new beat will begin, but that is not for now. For now, you are inside the old one, and it is enough. There is a point where human measures lose their meaning. The familiar distances, a road between towns, a horizon's curve, even the span between planets, dissolve into something so large that no step, no journey could ever contain it. You are beyond the reach of the ordinary now, moving through the hidden architecture of the universe. Here, space is not empty. It is a web. If you could step back far enough, farther than any eye has ever seen, the galaxies would stop looking like scattered lights. They would arrange themselves into strands and filaments, weaving together in luminous threads. The cosmic web stretches across the visible universe, its patterns shaped by gravity and the slow unfolding of billions of years. Each strand is not a line in the way a thread is a line. It is a chain of galaxies, hundreds, sometimes thousands, connected by invisible bridges of matter. Between them lie the great voids, vast dark regions that can span hundreds of millions of light-years across. These are not simply gaps. They are oceans of almost nothing, where galaxies are rare and the darkness feels deeper than anywhere else. The giants live along the filaments. They are not creatures in the way you know life. They are clusters of galaxies bound together by gravity into colossal cities of stars. The largest of these clusters hold thousands of galaxies, each with billions of suns. They are the most massive structures bound by gravity in the universe, and they move with a slow, steady grace, tugged by the pull of their neighbors and the invisible flow of dark matter. The scale is so large that even light takes hundreds of millions of years to cross from one side to the other. The life of a human being is less than a flicker compared to the time it takes for one of these giants to shift its position. You cannot witness their motion in real time. You can only trust that they are moving, guided by forces too vast to feel directly. You begin to sense how small a galaxy really is. Even one like the Milky Way, with its hundreds of billions of stars, is a bead in a necklace, one among many along a filament that spans a cosmic continent. These filaments themselves meet at nodes, dense knots where several strands intersect, creating the great clusters. In those knots, the giants are at their most crowded, galaxies swirling around each other like slow whirlpools of light. Between the filaments, the voids are still. They are not entirely empty. A few lonely galaxies drift in their depths, but compared to the richness of the filaments, they are deserts. And like deserts, they hold a strange beauty. In their darkness, the structure of the universe becomes more obvious. You can see the filaments as distant rivers of light, their gentle arcs defining the shape of everything. The giants are patient. They are the result of time working on the largest scales. In the early universe, matter was spread more evenly, with only slight ripples in density. Over billions of years, gravity magnified those ripples, drawing matter together into denser and denser regions. The densest became clusters. The spaces between them became emptier and emptier. It was not a sudden process, but a slow settling, like sediments forming layers on the ocean floor. Dark matter shapes it all, though you cannot see it. Dark matter outweighs normal matter by more than 5 to 1. It is the skeleton of the cosmic web, the unseen framework upon which galaxies form. Without it, the giants would not exist. It holds them together across distances where visible matter alone would drift apart. It binds the filaments, sustains the clusters, and keeps the web from dissolving into scattered dust. You try to imagine a map of this web. It would not be a flat drawing. It would be three-dimensional, more like a floating sculpture of glowing strands suspended in darkness. The nodes, the clusters, would shine like bright intersections, while the filaments stretch between them like glowing bridges. The voids would be deep shadows between the threads. And then you realize, this pattern is not local. It extends as far as we can see, and likely far beyond. Every part of the observable universe has its own web, its own giants and voids, all part of a single, seamless structure. It is humbling to think that the Milky Way, your home, is only one galaxy, in a small group, which itself is just a minor thread in one filament of this web. Even the most powerful telescopes cannot see its entire shape in one view. They can only reveal parts of the pattern which we stitch together in our minds. When you think about movement here, you have to change your sense of time. Galaxies in a cluster may take billions of years to complete a slow orbit around the cluster's center. Filaments shift gradually as gravity draws them toward one another. Even the voids change shape over cosmic ages, as matter continues to flow into the filaments and leave the empty spaces emptier still. The giants are not static. They grow. Every time two galaxies merge, the cluster gains mass. Every time gas falls inward and forms new stars, the glow of the filament strengthens. On the larger scales, the web becomes more distinct with age. The contrast between the filaments and the voids more pronounced. The giants are still being built, even now. You let your thoughts drift outward, following a filament across its immense length. Along the way, you pass small groups of galaxies, each one a world of its own, each one containing countless suns. Between these groups, the dark matter bridge is invisible but real, keeping them tethered to the structure. The distances are so great that even light, moving at its ultimate speed, would take longer than human history to travel between them. And yet, in the scale of the cosmos, these are neighbors. The giants do not rush toward each other. Their pace is set by gravity's pull and the counterforce of the universe's expansion. This expansion, on these vast scales, acts like a slow stretching of the web. Some filaments are drawn closer together, others are pulled apart. Over trillions of years, the pattern will change, but for now, it holds a frozen moment in an ever-changing dance. You think about the word giant and realize it is still too small. These are not merely large objects. They are frameworks upon which the visible universe hangs. They are the landmarks of all existence, the places where matter has gathered most tightly, the gravitational wells from which light can still escape, but only just. Even the giants are dwarfed by what they are part of. The web itself is the true colossus, and it stretches far beyond what any eye, human or otherwise, will ever fully see. In this realization, there is a kind of peace. The universe does not require you to understand it completely. It simply exists, vast and intricate, whether you are watching or not. The giants do not need your attention to continue their slow movements through the void. They have been here for billions of years before you, and they will remain billions of years after. But tonight, you are here with them. You can feel their gravity in the quiet of your thoughts. You can sense the threads that connect them, and through those threads, the connection to everything else. The void is not absence. It is space enough for the giants to breathe. And as you float here in the dark, you realize that size is not just about distance or mass. Size is about influence, the reach of a thing's presence through space and time. By that measure, the giants in the void are among the most powerful entities in the universe. They do not roar, they do not blaze, they do not move quickly, and yet they shape everything. Some of the most powerful things in the universe are the ones you cannot see. They leave no trail of light, no glow, no spark, only their influence. You feel them not through sight, but through the way they move, the things you can see. It is as if the cosmos has a second body, an unseen twin, guiding every visible motion, shaping the structures that hang across space. This is the domain of dark matter. The name is simple, but misleading. Dark suggests shadow, and matter suggests something familiar, tangible. But this is not the darkness you know, not the kind born of an absence of light. It is a different kind of invisibility, one that cannot be lit at all. Number, beam, no telescope, no reflection can reveal it, and yet it is everywhere. If the galaxies are the beads, dark matter is the string. If the stars are the leaves, dark matter is the wind. It is the hidden framework upon which the universe is built. a skeleton vast enough to cradle every galaxy ever formed. Without it, the luminous matter, the gas, the stars, the planets would be scattered like smoke, never settling into the grand shapes we see. You cannot touch it, but you live inside its reach. The proof of its presence is written in gravity's language. Galaxies spin too fast for their visible matter alone to hold them together. Stars on the edges should drift away into space, but they do not. Something unseen keeps them bound, pulling them inward with a steady, patient hand. When light from a distant galaxy passes through space, near a massive cluster, it bends, warped by gravity into arcs and curves. Often, the visible mass in the cluster is not enough to explain the strength of the bend. The rest of the mass, silent and invisible, is the shadow shaping the light's path. This bending is not an illusion. It is a truth of the universe. Space itself can be curved, reshaped by mass, even if that mass cannot be seen. You watch the light from a galaxy billions of light years away and realize it has taken a detour. A long, slow arc around something that leaves no visible mark. The shadow has moved reality without revealing itself. You think of deep ocean currents, the kind that never break the surface, but that move whole continents of water in silence. On the surface, ships drift, waves ripple, storms pass, but beneath there is a slow river, steady and unseen, guiding the course of everything above. Dark matter is that deep current, but on a scale far greater than oceans. It moves not water, but the very scaffolding of galaxies in the earliest days of the universe. Before the first stars burned, dark matter was already there. It gathered into invisible halos, dense knots in the fabric of space. These halos became the wells where normal matter pooled. Gas flowed in, cooled, and lit the first stars. Without dark matter's gravity, the cosmos might have remained a thin mist, scattered and dim. You begin to understand how deeply it shapes the world you know. Every spiral galaxy is wrapped in a halo of dark matter. Every cluster of galaxies is bound together by it. Even the great cosmic web, the filaments and nodes stretching across the universe, owes its shape to the distribution of dark matter. And yet, for all its influence, we still do not know what it is. We can measure how much of it there must be, about 5 times more than all visible matter combined, but its nature remains hidden. It does not interact with light, does not collide with ordinary matter in the way atoms do. It passes through the earth, through your body, without resistance, like wind through the branches of a tree. This unreachability does not make it less real. In fact, it may be the most certain ghost we have ever known. The evidence surrounds us, the rotation curves of galaxies, the lensing of light, the patterns in the cosmic web, the echo of the Big Bang itself. Every one of these whispers the same truth. There is more here than meets the eye. Sometimes you think about what it means for reality to be so thoroughly shaped by something you can never see directly. It is a reminder that the visible world is only a fraction of the truth. Most of what exists is hidden, and yet its fingerprints are everywhere. Dark matter does not shine, but it holds the stage light steady. It does not speak, but it shapes the script. It does not appear in the picture, but without it, there would be no frame. The more you dwell on it, the more you feel the quiet intimacy of its presence. Every motion of the Milky Way, every orbit of the Sun, every turn of the Earth is played out against the gravity of its halo. You are carried through space not just by the visible stars, but by this greater, unseen body that moves with you. It feels strange to think that you are inside something so vast. The halo of dark matter around the Milky Way extends far beyond the visible disk of stars, so far that if you tried to cross it, even at the speed of light, it would take hundreds of thousands of years. You have never left it. You have never even approached its edge. And this halo is not alone. Every galaxy has one, and together they link into the larger cosmic web, the invisible architecture of the universe, where halos overlap and connect. Clusters form, where they stretch into threads, filaments emerge, and between them, the voids, the empty rooms in the universe's grand design, grow wider, perhaps. The most humbling truth is that dark matter will remain long after the last stars fade. When the luminous universe goes dark, when even black holes evaporate, the skeleton will still be there, holding the shape of a cosmos without light. The shadows will outlive the stars. This persistence is part of the comfort it brings. The visible world is fleeting, stars burn out, galaxies collide, planets erode. But the unseen structure remains steady and patient, shaping reality for as long as reality exists. In the stillness of your thoughts, you can almost feel it. Not as a touch, but as an awareness. The sense that every direction you look, there, is more than meets the eye. The space between galaxies is not truly empty. The night sky is not truly dark. Every star you see is part of something larger, something held in place by hands you will never see. Dark matter asks you to trust without sight, to believe in a presence that can only be known through what it moves. And perhaps that is why it feels so familiar, because in your own life, much of what shapes you is unseen, too. The memories, the emotions, the quiet gravitational pulls of thought and connection, they bend your path just as invisibly. You let the thoughts settle. Reality is not just what you can see. It is what you can feel in the way the world moves. Even when the mover remains hidden, there is a weight so deep that it does not simply pull, it bends. It curves the very stage upon which existence plays, folding space into shapes you cannot walk across, and stretching time into rhythms that no clock could keep. Gravity is not just a tether. It is an artist shaping the geometry of the universe. Most of the time, you feel it as something gentle, the earth holding you close, the moon stirring the tides. But there are places where gravity stops being gentle, where it stops being a familiar friend and becomes something else entirely. You find yourself at the edge of one such place. It begins quietly, a slight curvature in the paths of stars, a subtle deflection of light. But as you move closer, the pull grows, and you feel the change in the way space itself behaves. The closer you are, the more space seems to stretch toward the center, as though every road leads there, as though all directions tilt into the same inevitable descent. This is the realm of black holes, places where gravity becomes so absolute that it locks even light inside. The word hole is misleading. There is no empty tunnel here, no cavern in space. A black hole is not the absence of something, it is the presence of everything, compressed into a point so small that its density defies imagination. The boundary around it, the event horizon, is not a surface you can touch. It is a line in spacetime, a threshold past which every possible path turns inward. Once crossed, there is no way back. You never see the black hole itself. What you see is the space around it, warped like glass, under pressure. If matter falls toward it, it heats and brightens, sometimes blazing with more light than an entire galaxy. But the black hole does not glow. It remains perfectly dark. The silence at the center of the storm. Gravity here is more than a pull. It is a cage. Outside the event horizon, light can still escape, but not without struggle. Time slows in its presence. From far away, you would see a clock near a black hole ticking more slowly than your own, the seconds stretching, the moments drawn thin. This is not illusion, it is the real shape of time in curved space. To the one near the black hole, nothing feels different. They live in their own pace, unaware of the distortion. But to the distant observer, they are falling into a deepening stillness, never quite reaching the horizon. The closer they come, the more their light is stretched into longer and longer wavelengths, fading into invisibility. This is the strange mercy of the event horizon. From the outside, you never witness. The crossing, the fall, appears endless. And yet, from the inside, the crossing happens in a moment, and there is no return. The idea that time itself can be caged is not unique to black holes. It is the nature of gravity itself. Every massive object bends space, and with it bends the flow of time. On Earth, the effect is tiny. You live your life without noticing that a clock on a mountain ticks a little faster than one at sea level. But near a black hole, the effect grows so strong that time nearly stops. There are other cages, two stranger ones, theoretical objects that may exist, born from mathematics and possibility, places where gravity twists spacetime into closed loops, where a path could lead you back to your own past, or naked singularities without horizons, where the heart of the gravitational collapse lies bare, and the laws of physics as we know them cannot hold. But even the known black holes, the ones we can detect and measure, are strange enough. They anchor the hearts of galaxies. In the Milky Way, the central black hole, Sagittarius A*, holds millions of suns worth of mass in a space smaller than the orbit of Mercury. Around it, stars move at breathtaking speeds, their orbits proof of the invisible giant they circle. Without it, the galaxy's center would be a far different place. Some black holes are much larger, massive, billions of times heavier than the Sun. The largest known can span the distance of our entire solar system. They are the ultimate cages, not just for light, but for whole star systems. When galaxies collide, their central black holes spiral together in a slow, titanic dance, eventually merging into an even greater mass. In these places, the familiar rules are bent beyond recognition. Space itself flows inward faster than light, can travel, carrying everything toward the singularity. Inside, the concept of place loses meaning. All directions end in the same destination. Time and space trade roles, as though reality itself reorders its priorities. And yet, despite this violence of form, black holes are quiet. They do not seek, they do not hunt, they wait. Everything that comes to them arrives of its own motion, carried by gravity's patient hand. You think about the paradox of the cage, that something can be utterly inescapable and yet utterly still. The black hole does not need to move to hold its prisoners. Its power lies in the shape it has carved into space-time, a shape so deep that nothing can climb out. There is beauty in that stillness, too. The light from nearby stars curves around the black hole's edge, creating a ring of fire, the photon sphere, where light orbits before deciding to flee or fall. Here, the universe's geometry reveals itself openly, as though showing you the sketches of its own design. If you could stand there, if standing were possible in such a place, you would see the sky distorted. every star bent into strange arcs. You would see your own reflection in the light looping round the whole, a ghostly echo of yourself. And behind it all, the dark center, silent and unbroken. The cage is not cruel. It simply is. It does not punish. It does not choose. Gravity is not a willful captor, but a law written into the structure of reality. And yet, the thought of it unsettles you. The idea that there are places in the universe where not even light, the fastest and most free thing you know, can escape. Perhaps the most haunting truth is that black holes are not eternal. Over unimaginable timescales, they evaporate through a slow quantum process, losing mass until they vanish in a final burst of energy. The cage dissolves. The prisoner disappears. What remains is only the memory written into the surrounding universe. The orbits changed, the stars swallowed, the paths bent long ago. Until then, they remain as they are now, silent anchors in a restless cosmos. You think of all the matter locked inside them, the remnants of stars, the gas clouds, perhaps even the occasional planet, all of it compressed into a singular point, the history of those objects erased, their shapes and colors lost to the darkness. The cage is perfect. It keeps not only bodies, but information itself. There is a deep humility in recognizing that even the most luminous things can end here. That brightness does not grant freedom, that speed does not grant escape. In the end, the shape of space decides the fate of everything, and perhaps that is why black holes feel so different from any other part of the cosmos. Stars live and die in cycles, galaxies change form, planets drift, but the black hole is absolute, a place where the rules do not bend but break. In the quiet of your thoughts, you sense the faint pull of such a place, even from unimaginable distances. It is a reminder that the universe is not only light and openness, but also depth and boundary. Gravity can be a cradle, holding worlds together. It can be a sculptor, shaping galaxies. But here, in its most extreme form, it becomes a prison, closing off all roads. Some things in the universe are old in ways that stretch your sense of time until it almost breaks. You think you know what ancient means, the slow crumbling of mountains, the endless flow of rivers, the fading light from distant stars. But the monsters you meet here have lived longer than any mountain will stand, longer than many stars will burn. They are the black holes born in the universe's youth, long ago, before the galaxies had fully taken shape, before the cosmic web was as clear as it is now. The first stars lit the darkness. They were giants, far larger and hotter than most stars alive today. Their lives were brief, a few million years at most, before they collapsed under their own weight. Some left behind neutron stars, dense but finite. Others fell past the point of no return, becoming black holes not much larger than a city, yet carrying the mass of dozens of suns. Those were the seeds. Given enough time and enough fuel, they grew. They swallowed gas and dust, pulled in smaller stars, and sometimes merged with other black holes. Across billions of years, some of these seeds became supermassive, sitting at the hearts of galaxies with masses millions or billions of times greater than the Sun. And there are hints that some monsters skipped the slow growth entirely, that they were born already massive, collapsing directly from enormous clouds of gas in the earliest cosmic dawn. These direct elapse black holes would have started their lives already among the largest objects in the universe. No one yet knows exactly how all of them formed, but whatever their origin, they have been here almost as long as there has been anything to be here at all. The oldest among them have watched the universe change. They have seen the first galaxies merge into larger ones. They have felt the slow thickening of the cosmic web. They have swallowed the debris of countless stars and drifted through long ages of quiet, between bursts of feeding. And when they feed, the universe notices. When a supermassive black hole swallows gas, that gas spirals inward, heating to millions of degrees. It releases light and energy so intense that it can outshine every star in its galaxy combined. We call these brilliant outbursts quasars, beacons, visible across billions of light years. A single quasar can blaze so brightly that it marks the presence of a monster in the dark, telling you that something enormous is awake and feeding. But not all are feeding now. Many of the largest black holes sit quietly, waiting for something to come too close. They are not gone, not even dormant, just patient. Their hunger is eternal, and in the depths of time, something always wanders into reach. It's strange to think of hunger without movement, without pursuit. But that is the nature of these monsters. They do not chase. They bend space so steeply that whatever crosses a certain invisible boundary, the event horizon can never leave. Their meals come to them, drawn by the inescapable shape they carve into reality. The monsters in the hearts of galaxies are not alone. Scattered through space are others, remnants of long-vanished stars. Black holes no larger than the moon in size, yet heavier than entire planets. Some drift through the outskirts of galaxies. Others roam the intergalactic dark, silent and unseen, relics from collisions and cosmic accidents. We cannot see them directly. We know them by the way they affect the things around them, how their gravity bends starlight, how they stir the motion of nearby stars, how they tug invisibly on their They are shadows in the fabric of space, shaping what they never reveal. Some theories suggest that even more massive monsters might exist. Black holes, so large they could swallow our solar system whole. The biggest known, at the center of a galaxy called Ton 618, has a mass more than 60 billion times that of the Sun. The scale is difficult to grasp. Its event horizon is so wide that a beam of light would take weeks to cross it. Weeks, just to traverse the very edge of its prison. You picture that scale, and it changes your idea of what large means. Mountains are nothing. Worlds are nothing. Even galaxies feel small next to the heaviest of these ancient creatures. And yet, size is not the most unsettling thing about them. It is the time they endure. While stars are born and die in bursts of brilliance, black holes persist. While galaxies change shape over eons, black holes sit at their centers, steady in their pull. The oldest among them have survived cosmic epochs that no living thing could witness from beginning to end. You wonder what it means for something to exist. For so long, without changing its nature, the universe has cooled, expanded, and scattered. Stars have come and gone. Elements have fused and broken apart. But the monsters remain what they have always been. Places from which nothing can escape. Perhaps they are not only ancient, perhaps they are eternal, or nearly so. Though physics tells us they will one day evaporate, their lifetimes stretch so far into the future that for now, they are as permanent as anything can be. There is a quietness to their age. They do not need to announce themselves. They are not in a hurry. They will wait for the next star, the next cloud of gas, the next unwary traveler to cross the horizon. And yet, you cannot shake the feeling that their stillness is not complete. that somewhere deep inside the event horizon, in whatever form matter takes when space and time collapse into one another, there is movement of a kind we cannot imagine, that the singularity, the hidden heart of the black hole, is not entirely still, even if it will never reveal its workings to the outside. For now, they rest. But rest, for them, is only the pause between meals, the breath between awakens. One day, something will pass close enough to rouse them again, and when they feed, their hunger will light the universe once more. The galaxies will flare with the brilliance of their accretion, and their influence will ripple outward, shaping the formation of stars and the growth of galaxies around them. It may be that these ancient monsters are not just destroyers, but also sculptors, that their outbursts seed the cosmos with the elements needed for life, that their energy stirs the gas from which new stars are born. They may be both the graveyards of the old and the cradles of the new. The thought is humbling. The same forces that swallow everything within reach might also help shape everything that follows. Death and creation, bound in the same silent form. As you drift in this thought, the scale of their lives begins to feel almost peaceful. The monsters are not malevolent. They are simply part of the order of things, vast, patient, and enduring beyond measure. You rest in the knowledge that they have always been here, and that they will remain long after the stars you see tonight have faded from the sky. Some hungers announce themselves. A star flares when it swallows gas. A quasar blazes with light that can be seen across billions of light years. The universe knows when these creatures are feeding. But there are other hungers that give no such warning. Hungers that take without sound, without light, without trace. These are the quiet black holes. They are not rare. In fact, they may be the most common kind, scattered through galaxies like shadows that never move. They sit in the dark, their event horizons perfectly still, their edges invisible against the backdrop of space. Unless something crosses that boundary, they cannot be found, and even when something does, there may be no great flare, no dazzling glow, only the quiet vanishing of what was once there. You cannot see them directly. The only way to know they are there is to watch for their influence. A star orbiting nothing, light bending where there should be no mass, the faint gravitational tug on nearby matter. They are ghosts that shape the living world. In this quietness lies a different kind of power. The black holes you have met before, the ones blazing as quasars, reveal themselves by their hunger. Gas falling inward heats up, colliding with itself, creating a whirlpool of matter so hot it radiates energy across the universe. But these quiet predators feed in a way that leaves no light. Their meals may be small or infrequent or swallowed so cleanly that nothing escapes to tell the story. A star might wander too close. Instead of a dramatic display, the star simply falls inward, its light stretched and dimmed until it disappears entirely. To the outside world, there is no sign of violence, only the sudden absence of a star that once was. You drift in the thought of such an ending, to be taken so completely that no echo remains, no light, no debris, no whisper. Perhaps this is why they are so difficult to find. Even in our own galaxy, there may be millions of them, each no larger than a city, yet heavier than entire suns, passing silently among the stars. Some may drift through the thin outskirts of the Milky Way, others may hide in the dense regions, where stars are close together. Some may wander the space between galaxies, untethered. Their only companion, the darkness itself. The hunger is always there, but it is not restless. These black holes do not chase what they consume. They simply wait, patient as stone, until something crosses into their domain. Once it does, the outcome is certain. There is no resistance that matters, no force that can push back against the shape of space-time they have carved. And this is the strange thing. In a universe so vast, these silent predators are almost harmless to most of what exists. Space is mostly empty. Stars are far apart. Planets and gas clouds drift in orbits that keep them safely distant. It may be millions, even billions of years before a quiet black hole finds its next meal. But time is on their side. On scales this large, patience is a kind of inevitability. Given enough ages, every wandering star will pass close to something it cannot escape. Every gas cloud will one day be drawn into a deeper gravity well. For a black hole, the question is never if, only when. There is a purity to this kind of waiting, no wasted motion, no need for display, hunger without urgency. You think about the ways these invisible objects shape their surroundings without ever being seen. A star in orbit around one moves in a perfect, graceful path, tracing an ellipse around what appears to be empty space. From a distance, you could chart that orbit, calculate its speed, and discover the weight of the unseen partner. A weight so great that only a black hole could explain it. Some of these quiet black holes travel through space, the result of ancient collisions that have kicked them away from their homes. When galaxies merge, their central black holes spiral toward each other. Sometimes, when they finally merge, the recoil from their union sends the new, larger black hole flying through space at thousands of kilometers per second. Such a wanderer might pass through a galaxy without stopping, swallowing only what drifts, too close before moving on. It is possible that one could pass through the outskirts of our own galaxy. If it did, you would not see it. You would not feel it. The only clue would be a slow, careful study of the stars it disturbed as it passed. The idea is both unsettling and strangely calming. Unsettling, because something so massive could be so close without your knowing. Calming, because it is a reminder of how much of the universe is not aimed at you. How much exists without malice or design, simply moving through space according to the same rules that guide everything else. There is another kind of quiet hunger to the black hole that feeds not on stars, but on dark matter. Dark matter does not interact with light, but it still feels gravity. If a black hole drifts through a region dense with dark matter, it may grow without a single spark of visible energy, swallowing matter that the rest of the universe cannot see. This is hunger layered upon hunger, the unseen consuming the unseen. Such growth leaves no trace except in the mass of the black hole itself, which swells over eons like a stone, slowly gathering the weight of dust. In this way, the quietest black holes may be among the most ancient and the most massive, growing not through bursts of violent feeding, but through a steadily invisible draw. You let your thoughts settle on the nature of their invisibility. It is not the invisibility of hiding, nor the invisibility of something too small to see. It is the invisibility of perfect absorption. These are objects without surface, without reflection, without a way for light to leave. They do not turn dark because they lack light. They are dark because they are the end of light's journey. Even the name black hole feels inadequate. It suggests absence, a void. But in truth, a black hole is a place where everything is present, so tightly gathered, that there is no space left for anything to move outward again. The hunger without light is not only about consumption, it is about permanence. Whatever falls in becomes part of it forever, carried into the singularity, where the known laws of physics fall silent. From the outside, you can never learn what has become of it, and yet, even in their quiet, they shape the future. A star that falls into a black hole will no longer shine on its planets. A cloud of gas swallowed in silence will no longer form new suns. Over time, enough silent feedings can change the pace of starbirth in a galaxy, steering its evolution in ways that may never be obvious to casual observers. It is strange to think of such stillness as an active force, but it is. The quiet black holes are sculptors, removing pieces from the universe's visible form and storing them in a darkness that will hold them for longer than the lifetime of any star dot in the end. Their invisibility may be their most defining feature, not because it makes them mysterious to us, but because it allows them to exist in such vast numbers, unnoticed yet unending in their influence. You picture one now, drifting slowly through space, surrounded by stars it will never touch. It moves without light, without sound, without a trace in the electromagnetic spectrum. And yet, its gravity reaches across light years, shaping the paths of things that will never see it coming. It waits. It has always waited. And it will continue to wait until the rare moment when hunger and opportunity align. Not everything hidden in the universe wears the shape of a black hole. Some things conceal themselves in quieter ways, in forms that leave no edge, no boundary, no sudden drop into darkness. They do not blaze, and they do not bend light into arcs that betray their position. They are harder to sense, harder to name, yet they are here, woven into the structure of reality itself. You begin to realize that the visible universe, the stars, the glowing gas, the bright galaxies, is only the thinnest skin stretched over something far larger. Beneath it lies the greater mass. The things you cannot see. Some of these unseen things are made of matter we do not yet understand. You call it dark matter for want of a truer name. But that name says only what it is not luminous, not visible. It moves in silence, yet its weight bends space just the same. It shapes the paths of galaxies, threads the cosmic web, and builds the scaffolding on which the visible universe rests. You picture it as an invisible continent beneath a shallow sea. The waves and ripples on the surface, the galaxies, the stars, are the only things you can see. But the continent below determines the depth, the flow, and the shape of every motion above. And then there are the voids, the vast, silent chambers between the threads of the cosmic web. They are not simply empty spaces. They are regions where almost nothing ever formed. The largest of them could swallow hundreds of galaxies and still feel hollow. In their darkness, you lose all sense of scale. Without stars for reference, without any light to measure, space becomes something unanchored, stretching away in all directions without end. Some voids are so large they push against the edges of human comprehension. To cross them, even at the speed of light, would take hundreds of millions of years. They are not just places, they are absences, so complete that they become part of the architecture of the cosmos, just as solid in their shape as any cluster of galaxies. You drift in thought about how emptiness can be a presence of its own. A void is not simply the lack of something. It is the existence of a space defined by its quiet. It is the still air between notes in music, the pause that shapes the sound, and then you consider the stranger. Possibilities, the unseen masses that may not be made of matter as you know it at all. Perhaps there are relics from the earliest Moments after the Big Bang, when the universe was hot and dense and full of energies never repeated since. In those first fractions of a second, space itself might have knotted and folded, leaving behind objects without light, without form, yet heavy enough to warp the paths of everything near them. They might be vast clouds of primordial gas, never condensed into stars, still floating cold and invisible between galaxies. Or they could be colossal, starless bodies, giants made entirely of dark matter, undetectable except by the way their gravity brushes against passing light. You cannot tell if these things are alive, but there is something in their silence that feels deliberate. They move through space as though they know where they are going, carried by currents you cannot map. And if they do not know, if they are simply drifting, then their stillness is even stranger, a reminder that not everything in the universe is restless. In a way, they are more elusive than black holes. A black hole announces itself when it feeds. The things you cannot see may never announce themselves at all. You might spend centuries looking for the faintest sign, the smallest wobble in a star's path, the tiniest distortion in a background galaxy, before you even suspect they are there. And yet, their fingerprints are everywhere. You see it in the way galaxies cluster together, pulled along invisible lines. You see it in the maps of cosmic microwave background radiation, where tiny fluctuations mark the seeds of the structures that would grow billions of years later. You see it in the way the largest scales of the universe form patterns that could not exist without something more than the matter we can see. It is humbling to remember that your understanding of the cosmos rests on shadows, on the influence of things you cannot touch or measure directly. It is like mapping a forest by the sound of wind in the leaves, without ever seeing the trees. The mind naturally wants to fill the darkness with shapes. You think of predators in deep oceans, drifting unseen until they move. You think of clouds, so faint they pass in front of your eyes without notice. You think of mountains shrouded in fog, their weight felt but their peaks hidden. But here, the scale makes those images feel fragile. A dark matter halo can wrap an entire galaxy in its invisible grasp. A cosmic void can span hundreds of millions of light years. A primordial cloud can drift for billions of years, without meeting anything dense enough to disturb it. It is not that they are rare, it is that they are patient, and their patience stretches far beyond the reach of your own. Some astronomers have tried to name the strangest of these shadows: dark galaxies, ultra-diffuse galaxies, cold streams, but names only capture a fraction of their truth. They are part of the same great tapestry, woven from threads that the eye will never catch. And perhaps this is what makes them feel alive, the way they interact with what you can see, as if the visible and invisible are partners in a slow dance. Galaxies spin because of the pull of unseen matter. Clusters form at the intersections of invisible filaments. Even the empty voids help shape the paths of the structures around them. The universe is not divided into what you can see and what you cannot. It is made of both, equally. One is the outline, the other is the canvas. The thought leaves you with a kind of quiet awe. For all your searching, for all your maps and instruments, most of reality still lies hidden. The things you cannot see are not failures of perception. They are reminders of the depth that still waits beyond your reach. And so you drift, knowing that in every direction there are presences without faces, masses without light, and regions so empty that their emptiness itself becomes a form of existence. Gravity does not always fall straight down. Sometimes it spreads, flowing outward like water pressing against the shore, retreating only to return again. It is not only a force, but a motion, a tide that moves through space and time, shaping everything in its reach. You are used to thinking of gravity as a pull, the invisible string between you and the Earth, between planets and their suns. But on the larger scales, gravity is less like a string and more like the gentle heave of an ocean. The fabric of the universe swells and bends, carrying whole galaxies in its slow currents. If you could step far enough back to see the grandest patterns, you would notice that space is never still. Galaxies drift not only because they are moving through space, but because space itself is moving. It stretches in some places and gathers in others. A vast tide flowing through a sea whose edges are too far to imagine. These tides are not made of water or wind, but of the bending of spacetime itself. Where matter gathers, space curves inward, drawing nearby objects toward the center. Where matter is sparse, the curve is gentler, and objects drift outward more freely. Over billions of years, this uneven bending shapes the architecture of everything. The great filaments of galaxies, the vast voids between them, the slow migrations of clusters. You are inside one of these tides now. You have always been inside one. Your galaxy is not fixed in place. It moves along a thread of the cosmic web, drawn toward regions of greater mass, pushed away from vast expanses of emptiness. This motion is not sudden. It is almost impossibly slow from your point of view. But given enough time, these small, steady pulls and releases guide the fates of entire clusters of galaxies. It is a motion you cannot feel, and yet you are carried in it, just as a drifting boat does not feel the current that carries it to a distant shore. On smaller scales, you see gravity's tides in the orbits of moons and planets. The moon raises tides on Earth, pulling the oceans so that they bulge toward and away from it. The sun raises tides on the planets, stretching their paths into ellipses. Even you, standing still, feel the gentle difference in gravity between your head and your feet, too small to notice, but real. On the scale of galaxies and clusters, the effect is the same, only grander. Two massive clusters draw on each other. Across tens or hundreds of millions of light years, their mutual pull distorting the paths of galaxies in between. Entire filaments bow and sway under the influence of these tides. The image forms in your mind. The universe not as a static map of stars, but as a living, shifting fabric, flexing under the weight of its contents. Where the mass is greatest, the fabric dips. Where the mass is absent, it rises. And in between the tides run slow, steady rivers of motion that carry everything. These tides are more than motion, they are memory. The shape of the cosmic web today is the result of billions of years of tides. In the early universe, matter was almost evenly spread, with only small variations in density. Over time, gravity gathered the slightly denser regions into larger structures, while the emptier regions emptied further still. The tides carried galaxies toward one another, where they merged and grew. They swept matter into filaments and walls, and they deepened the voids between them. Even now, the tides continue their work. The Milky Way, along with its neighboring galaxies, is falling toward a region astronomers call the Great Attractor, a concentration of mass so large that it pulls on everything nearby. We are part of that slow migration, moving through space at hundreds of kilometers per second, not toward any single star or planet, but toward a deeper curve in the fabric of spacetime. You cannot feel this motion because everything around you moves with you. The Earth, the Sun, the other stars of the Milky Way, all are passengers in the same current. But if you could watch from far outside, you would see our galaxy's long, slow drift, carried like a leaf on the largest tide you can imagine, and there are greater tides still. On the scale of the observable universe, even the largest clusters are not fixed points. They shift under the combined influence of everything around them, drawn toward some regions, pushed away from others. And beyond the reach of our telescopes, the pattern continues, the tides flowing through a cosmos larger than we can ever fully see. It is strange to think that what feels solid, the place where you stand, the stars you see each night, is part of something so fluid. That stability itself is only an illusion born from moving with the current. In this way, the tides of space are both sculptor and storyteller. They decide where galaxies will grow, where clusters will collide, and where empty space will remain, untouched for eons. They hold the record of the universe's history, written in the arcs and flows of its structures. You are not separate from this story. You are carried in it, shaped by it, even as you move through your own small tides. The pull of the moon on the oceans, the pull of the sun on the earth, the pull of the Milky Way on your solar system. Each is part of the same great continuum. From the smallest shift to the largest curve, there is a kind of peace in knowing that you are not adrift. The tides may be invisible, but they are constant, and they bind the universe together. Every galaxy, every star, every grain of dust is part of the same vast motion. Perhaps that is why the night sky feels so still. The movement is too slow to see, too large to hold in the mind, and yet it is always there. The silent, patient breathing of the cosmos in the stillness of space. Collisions are not the sudden, shattering events you know from the world beneath your feet. Here they are. Slow convergences, drawn out over hundreds of millions of years. Two galaxies meet not with the crack of breaking stone, but with the deep, silent folding of tides. You imagine them from afar, like icebergs adrift on a boundless ocean. Their shapes approach, their outlines blending until they are no longer two, but one. The scale is so vast, the movement so slow, that to witness even the first moments of such a meeting would require a lifetime beyond measure. A galaxy is mostly empty space. The stars within it are so far apart that, when galaxies collide, most of those stars simply pass by each other. There are no fiery impacts, no planetary wreckage scattered through space. Instead, the change comes from gravity's patient rearrangement, the slow reshaping of orbits, the gentle pulling apart of spirals into long, curving streams. And yet, within that quiet grace, there is violence. The vast clouds of gas and dust that drift between the stars do not pass so easily. They crash and compress, igniting bursts of star formation. Whole generations of stars are born in the wake of these collisions, lighting up the merging galaxies in brilliant, short-lived fire at the very centers. Something deeper stirs. Most galaxies hold a black hole at their heart, a silent anchor, often millions or billions of times more massive than the Sun. When two galaxies merge, their central black holes are drawn together in a long spiral, each orbit tightening under the pull of the other. For millions of years, they dance around one another, their motion sending ripples through spacetime itself. Those ripples are gravitational waves, faint, slow undulations in the very fabric of the universe. They travel outward at the speed of light, carrying the story of the merger to the farthest reaches of space. By the time they arrive at our instruments, they are so subtle that only the most sensitive detectors can catch them. Yet they are proof of something immense, that two giants have become one. When they finally meet, the union is absolute. Their event horizons fuse, their singularities join. The result is a black hole more massive than either was before, a new giant that will settle back into stillness, waiting for the next time the universe calls it to move. These collisions are not rare. Across the history of the cosmos, they have been one of its most powerful forces for change. Without them, galaxies would not have grown to the sizes we see today. Without them, the great ellipticals, swollen with ancient stars, would not exist. Even our own Milky Way is part of this story. In about 4 billion years, it will meet the Andromeda Galaxy in a slow embrace. From our vantage point within one of its spiral arms, the change will be gradual, almost imperceptible at first. A shift in the pattern of stars, a soft distortion in the familiar constellations. Over millions of years, the two galaxies will weave together, their spirals torn and reshaped into long streams. Eventually, they will settle into a new form, neither Milky Way nor Andromeda, but something born from both. There is no way to stop. Such meetings, they are written into the movement of the cosmic web, determined by the same tides that carry clusters and filaments across the vastness. And so, the universe grows not only through the birth of stars, but through the merging of its largest structures. Each collision leaves a mark. The trails of stars flung into intergalactic space, the dense knots of new starbirth, the swollen black holes at the centers. If you could see the history of a galaxy in its entirety, you would see a lineage of such meetings, each one reshaping its form and its fate. The aftermath of a collision is not just physical. It changes the pace of time within the galaxy. Star formation may surge for a while, then fade as the available gas is used up. The galaxy may become quieter, more settled, its brightest days behind it. The giant at its center may fall into a long sleep, waiting for the next supply of matter to drift within reach. In this way, collisions do not only create, they also conclude. They close certain chapters in the lives of galaxies, even as they open others. You begin to see the pattern. The universe is built not from isolated events, but from a chain of encounters. Every galaxy you see tonight is the result of countless smaller galaxies meeting and merging in ages past. Every spiral arm, every halo of stars, every massive black hole is a record of those long, slow convergences. And there are subtler forms of these meetings. Sometimes, a smaller galaxy is drawn into a larger one, consumed without much disruption. To the greater structure, these minor mergers still add mass, still feed the central black hole, still leave faint streams of stars trailing in their wake. They are quieter, but they are part of the same great rhythm. Other times, galaxies pass, close enough to disturb each other without fully merging. Their shapes are tugged and twisted, their stars sent into new orbits, their gas compressed into new waves of starbirth. Then they drift apart again, carrying the marks of the meeting for billions of years. You think of these as the near misses of the cosmos, though in truth, even such passing encounters are part of the same deep choreography. Through all of this, there is a remarkable patience. Nothing rushes. The distances are too great, the masses too heavy, the movements too slow for haste to matter. The universe does not hurry to its conclusions. It lets gravity work at its own pace, letting the shapes of galaxies shift like clouds in a wind. You cannot feel. It is a reminder that change does not have to be sudden to be profound. The most transformative events in the universe can happen so slowly that no single moment feels like the turning point. And yet, when you look back across the ages, the change is complete. There is beauty in this slowness. To watch two galaxies merge is to watch the steady weaving of a new design into the fabric of the cosmos. The threads are made of stars, the loom is gravity, and the tapestry stretches far beyond your sight. Each merger is a pattern that will remain for billions of years, even as new patterns form elsewhere. When you look at the night sky, some of the faint smudges of light you see are galaxies in the midst of such collisions. They are not dangerous explosions, but slow transformations, their shapes still in motion, their futures still unfolding. And perhaps the most striking truth is this: without these collisions, the universe would be emptier, quieter, and far less diverse. It is the meeting and merging of galaxies that builds the variety of forms we see, from delicate spirals to massive ellipticals. It is their unions that grow the black holes at their centers into the giants that shape the fate of stars. Every collision is both an ending and a beginning, the end of two separate paths, the beginning of one shared journey in the deep quiet of space. The memory of these meetings lingers. The trails of stars that stretch beyond the edges of a galaxy are reminders of the moment when it was something else, when it shared the sky with another in a long, slow dance. And somewhere, even now, galaxies are drifting toward each other, their fates sealed by the pull of gravity. They do not know they are moving. They do not feel the inevitability of their meeting. They simply follow the curves in the fabric of space, carried toward a future in which they will no longer be alone. There are motions so immense that the fabric of the universe itself must respond, when something truly massive changes its state. When it falls, when it collides, when it spirals into another of its kind, space and time cannot remain still. They shift, they flex, they send the news outward. This news does not travel as light or sound. It moves as a tremor in the very shape of reality. A gravitational wave. You cannot see these waves. They do not shimmer or leave trails, but they are everywhere, always moving, always passing. The earth, your body, the air you breathe, all of it is carried along with them, stretched and squeezed in ways so slight you would never notice without the most delicate instruments. And yet, these changes are not illusions. They are real deformations of space itself, rippling outward from events that may have happened before life began. The source of such waves is always something extraordinary. Two black holes spiraling together, two neutron stars colliding, giants meeting in silence, their immense gravity twisting the geometry around them. Every orbit draws them closer, every loop sends a faint pulse outward, until at last the collision comes, and the final strongest waves begin their long journey through the universe. They travel at the speed of light, but unlike light, they are not dimmed or absorbed by the things they pass. They move through everything, through dust clouds, through stars, through entire galaxies, without pause. They carry their message unchanged for billions of years, until they arrive in places that could never have guessed they were part of the story. You live in such a place. Right now, as you listen, gravitational waves from countless ancient events are passing through you. Some are strong enough to be caught by the great detectors humans have built. Long arms of laser light measuring distances that shift by less than the width of an atom. Others are so faint they blend into a cosmic background too quiet for us to hear yet, but still there, humming softly through the fabric of everything. It is easy to forget that space and time are not rigid. You think of them as the stage on which events occur, unchanging and fixed. But they are more like a woven cloth, able to stretch and ripple. Every massive movement tugs on the threads. Every collision sets the cloth quivering. The waves do not need an atmosphere to carry them. They do not need matter at all. They move because space itself can flex, the way the surface of water can rise and fall when something disturbs it. The first waves we ever detected came from the merger of two black holes more than 1 billion light-years away. By the time their signal reached us, the event was long over. The black holes now fused into one. The waves were faint, almost imperceptible, but they carried a precise record of what had happened. The masses of the black holes, their final speed, the exact moment of their union. In that moment of detection, the universe revealed a new way of listening. Gravitational waves are not just another form of light. They are a way to sense things that light cannot show. A black hole gives off no light, but when it moves or merges, the ripples it sends are unmistakable. Even in complete darkness, you can still feel the motion. It is a strange form of hearing, one that works without ears, without air, without sound. But it is hearing in the truest sense, the perception of vibration, the reading of patterns in waves. If your senses were tuned to them, you might experience the cosmos differently. You might feel the passage of a wave the way you feel the brush of wind, a gentle squeeze and release of space all around you. Each wave would be a note in a symphony that began billions of years ago, played by instruments the size of suns. Some waves are quick, sharp bursts from sudden events, the final moments before a merger, when massive bodies whirl around each. Other at a fraction of the speed of light. Others are long, slow undulations from vast systems, still in the early stages of their spiral, taking millions of years to meet. And beyond these individual notes lies the deep background hum, the combined effect of countless distant collisions layered together. This background is the ocean in which all other waves travel. We have only begun to sense it, like feeling the faintest thrum of a drum through the floor. But as our listening becomes more precise, we will hear more of the ocean's rhythm and the stories it carries. Gravitational waves are proof that even the most violent cosmic events leave something gentle behind. They are not explosions of light or shouts across space. They are whispers, so soft, so subtle, that the universe itself must be still for us to hear them. And yet, their quietness does not mean they are weak. A single wave from a merger can pass through the entire universe, without fading, altering space as it goes. It does not matter how far it travels, it will always arrive. You think about the patience in that. A message sent without knowing if it will ever be received. A wave moving through billions of years and billions of light years with no guarantee of an ear or an instrument to hear it. And yet, when it finally is heard, the moment is complete. The story finds its listener. There is something deeply human in that thought. The idea that a signal, no matter how faint or delayed, might one day be understood, that the motion of giants, long gone, can still touch us across the gulf of time. The waves passing through you now are not the end of their journey. They will keep going, crossing more galaxies, touching more worlds, bending more threads of spacetime. They are not bound to one place or one moment. They belong to the entire fabric. Perhaps, one day, someone far away will detect the same wave you are feeling now, and they will know the same story. Perhaps, in this way, the universe shares itself, not in images, but in movements too deep for light to carry. And if you let yourself imagine it, You can almost feel the shape of the fabric shifting around you, not violently, not sharply, but with the gentleness of a long, slow breath. The wave moves on, and you remain unchanged, yet slightly different for having been part of its path. Cold, you were told, is the natural state of space. The further you travel from stars, the more you leave their warmth behind. The more the temperature falls toward an endless night. But the truth is softer, more complicated. Even in the darkest reaches, space is never truly frozen. It carries a faint warmth, so faint that you would never feel it, yet so steady it has survived for billions of years. This heat is not the gentle glow of nearby suns. It is older, more patient. It is the whisper of events that once shook the cosmos, lingering in the quiet between galaxies. Much of it lives in the vast spaces between the great clusters, in clouds so thin they hold only a few atoms in every cubic meter to human senses. These regions are emptier than emptiness, but they are not still. Those atoms move, they vibrate, they carry the memory of heat, and this memory is stubborn. A cloud of gas in deep space can remain warm for longer than the age of Earth itself. Out here, there is almost nothing to steal that heat away. No dense surface to conduct it into, no thick air to carry it off. The atoms drift, colliding only rarely, giving up their energy so slowly that the warmth becomes nearly eternal. Some of this heat was born in the violent youth of the universe, when galaxies were young and collisions were common. Massive stars exploded in supernova, sending shockwaves into the gas between galaxies. Jets from the hearts of active black holes blasted through space, stirring and heating whatever they touched. Those moments ended billions of years ago, but the warmth they created lingers still, like the fading ring of sound after a bell has been struck. And there is another kind of heat, quieter, but even more enduring, the faint afterglow of the Big Bang itself. The entire universe is bathed in it. It is not hot by earthly standards, just a few degrees above absolute zero, but it is everywhere, filling every gap, touching every particle. This cosmic background is a reminder that the universe began not in cold, but in unimaginable heat, and that some of that first fire still hums through space. The heat that never cools is a storyteller. It carries information about the past in the way it is spread, in the patterns of its faint ripples. Scientists mapped this background, searching for the fingerprints of the forces that shaped the universe, when it was less than a heartbeat old. But even beyond that universal afterglow, there is warmth in places where you would expect none. In the long filaments of the cosmic web, in the space between clusters, thin streams of gas hold temperatures of millions of degrees. They are too diffuse to shine brightly, yet they radiate softly in wavelengths we cannot see. These warm threads are the quiet rivers of the universe, linking galaxies together, feeding them over time. They are stirred not by the present, but by the echoes of the past, the collapse of great structures, the infall of matter into deep gravitational wells, the shock of two galaxy clusters meeting in slow but unstoppable collisions. You think of these spaces as calm, but they are not entirely still. The motions are too slow for the human eye, but over millions of years the gas flows, swirls, and spreads, carrying its heat with it. The presence of this warmth changes everything. Without it, matter in the voids might collapse too quickly, forming stars and galaxies in ways that would erase the patterns we see today. The heat holds the pace of creation in balance, slowing some processes, feeding others, guiding the growth of the cosmic web like a gardener tending a slow, vast garden. In this sense, the heat that never cools is a hidden regulator of the universe. It does not burn fiercely. It does not fade quickly. It simply persists, influencing without dominating. Some of the warmest places in space are also the most remote. The centers of galaxy clusters can hold gas heated to tens of millions of degrees, trapped there by the cluster's immense gravity. This gas can remain hot for billions of years, kept from cooling by the energy of black hole outbursts in the cluster's central galaxy. In this way, the largest black holes do more than consume, they also maintain, pumping heat into the surrounding medium and preventing it from collapsing too quickly into new stars. It is a cycle both strange and elegant. The most extreme engines in the universe, quietly sustaining the conditions around them. You might think that heat is a fleeting thing, something that dissipates quickly, something temporary. On human timescales, this is true. Fires burn out, metal cools, the warmth of a touch fades. But the universe measures time differently. In its scale, heat can be a near-permanent companion. Even now, as you drift in thought, your body is bathed in this faint cosmic warmth. You do not feel it. You could not survive on it. And yet, it is there, the same everywhere. Whether you are looking at the stars above a mountain or imagining the dark expanse between galaxies, this unending heat is not just a physical fact. It is a reminder of connection, that even the most distant regions, even the most forgotten corners of space, still carry the memory of the same beginning. Every point in the universe shares this background, this faint echo of the first fire, and somewhere in that warmth, in the details of its ripples and flows, there may be secrets still waiting. The arrangement of its patterns could tell us about forces that have left no other trace. The temperature of its hidden clouds could reveal the quiet work of ancient black holes. The way it clings to emptiness could whisper the history of events we cannot see. The heat that never cools is not simply a relic. It is an active presence, still shaping the paths of matter, still influencing the future. It does not fade into irrelevance. It remains as part of the framework upon which the universe grows, and so, space is never truly cold. Even in the deepest void, there is a trace of fire, the quiet persistence of energy that will outlast stars, outlast galaxies, perhaps even outlast the memory of light itself. Most of the time, the giants sleep. They rest in the hearts of galaxies, wrapped in darkness, their presence marked only by the way stars curve around them. Their hunger is constant, but not always fed. They can wait for millions of years without stirring, but every so often, something changes. A cloud of gas drifts too close. A star is nudged inward by the motion of others. A galaxy passes near enough for its gravity to spill matter toward the center. The stillness begins to shift, and then the waking begins. At first, the change is invisible. Far from the center, you would notice nothing. The outer stars continue their quiet orbits. The spiral arms hold their slow patterns. But closer in, the darkness thickens. Matter begins to fall toward the event horizon, accelerating as it comes. It cannot fall straight in. Like water circling a drain, it forms a disk, whirling faster and faster, compressing under its own motion. Friction between the spiraling streams of gas heats them until they burn hotter than the cores of stars. The black hole does not glow. It never will, but the disk does. It shines with such intensity that it can outshine the entire galaxy around it. From across the universe, it appears as a brilliant point, a quasar, a beacon from the center of a faraway world. These beacons are not gentle, they are powered by destruction on a scale almost beyond imagining. Matter transformed into energy with an efficiency no star can match. For every ounce of material that crosses the horizon, a portion of its mass is released as light, radiation, and jets of particles that can stretch for millions of light years. The awakening of such a beast changes everything around it. The intense radiation can heat and scatter the gas in its galaxy, quenching the birth of new stars. Or it can compress clouds on the edge of its influence, sparking star formation in sudden bursts. The galaxy's future is rewritten in the light of its awakened heart. Some awakenings are brief, a flare that lasts only a few million years before the fuel runs out. Others burn for longer, sustained by a steady flow of matter, but none can last forever. Eventually, the gas is gone, the star is consumed, the nearby space is swept clean. The giant sinks back into stillness, carrying the memory of its feast. And yet, in the deep stretches of cosmic time, another meal will come. The cycle will repeat. When you look into the night sky, most galaxies appear calm. Their central black holes are dormant, hidden in darkness. But the light from quasars reminds you that some are awake, and that the same could happen here, in the Milky Way. Sagittarius A*, the black hole at our galaxy's center, is quiet now. It glows faintly in radio waves, but not in the blinding light of a true quasar. Yet traces in the gas near the center suggest that it has awakened before. There are signs of past outbursts, bubbles of hot plasma stretching far above and below the galactic plane, relics of a time when it may have fed more greedily. If it woke again, the change would not threaten the Earth. Directly we are too far from the center, but the galaxy's appearance would alter. The core would blaze brighter than any star in our sky, visible even in daylight. For millions of years, its light would travel outward, announcing to the universe that the Milky Way's giant had stirred. In distant galaxies, the same story plays out now. A quasar's light reaches us after billions of years of travel, meaning that many of the ones we see today have already gone quiet. We are witnessing awakenings from a time when the universe was younger, more crowded, when collisions and mergers fed the giants more often in that earlier age. The night sky of any inhabited world would have been busier, brighter with the light of active quasars. The universe itself seemed more restless, more willing to feed its greatest beasts. The awakening of a quasar is not only a moment of consumption, it is also an announcement. Its light travels in all directions, a signal to the cosmos that something immense is happening. And unlike gravitational waves, which pass through without resistance, light can be blocked, scattered, or absorbed. Even so, the most luminous quasars are visible across distances that span most of the observable universe. It is as though each one is a lighthouse, sending its beam through seas of darkness, though the ships that might see it are not sailors but galaxies, and the sea is the fabric of space. Some quasars send more than light. They hurl out jets, narrow beams of plasma accelerated to nearly the speed of light, punching through their host galaxies and far beyond. These jets can extend for millions of light years, carrying energy into the intergalactic medium, stirring the thin gas between galaxies. This too reshapes the universe. The jets heat and displace the gas in their path, changing the conditions for future galaxy formation. They can create vast lobes of radio emission, ghostly shapes that remain long after the quasar itself has faded. You think of the black hole as a predator, but in these moments it is also a sculptor, carving structures into the space around it, leaving behind forms that will persist long after the light is gone. The waking of the sleeping beasts is part of the grand cycle of cosmic change. It is not constant. It is not evenly spread. It is a rhythm with long silences, sudden crescendos, and fading echoes. If you could watch a single galaxy for billions of years, you would see its heart brighten and fade many times. Sometimes the awakenings would be triggered by chance, a stray cloud drifting inward. Sometimes by violence, the merger of two galaxies, funneling rivers of gas toward the center. And sometimes by tides, the slow rearrangement of orbits that, given enough time, brings something too close to resist. The fact that we see so many quasars in the distant universe tells us that this waking was once more common. The further we look back in time, the more active the giants seem. In the present, most have grown quiet, their fuel supplies depleted or locked away in stable orbits. But the quiet is only temporary. Even now, there are signs. In some galaxies, faint disks of hot gas swirl at the center, as though the beast is breathing in its sleep. In others, bursts of radiation flare unpredictably, like the twitch of a dream. These could be the first stirrings, the signs that another awakening is coming, and somewhere, deep in the dark, one has already begun. The first trickle of matter is falling inward. The disk is forming. The heat is rising. Soon, its light will break free, racing outward into the universe. Millions or billions of years from now, it will reach some distant observer, who will see it as we see the quasars of today, as a point of impossible brightness in a field of stars. For them, the awakening will already be over. The light will be a memory, a ghost of an event they cannot touch, but it will tell them that, once, in that galaxy, the giant stirred. You wonder how many such awakenings are happening right now, scattered across the observable universe. How many hearts are flaring into life, unseen by us, because their light has not yet arrived. The sky you see is a record of the past, but beyond that horizon lies the present, full of moments you will never witness, yet which are as real as the stars above you now. The sleeping beasts do not wake in unison. Their rhythm is scattered, uncoordinated, each moving to its own gravitational clock. But taken together, they are part of a larger pattern, one that stretches across cosmic history, the alternation between stillness and activity, between dark and light. Perhaps the universe needs both, the quiet to build, the waking to transform, the stillness to gather, the flaring to release. You rest in that thought, aware that you live in one of the quiet eras, a time when most giants are sleeping. But somewhere ahead, in the deep future, there may come another age of light, when many will stir again, and the night sky will be marked with their beacons. You take comfort in the stillness of the night sky. The constellations hold their shapes. The galaxies remain where you left them, and the light of distant stars seems eternal. The sky feels like the one constant in a world of change, but nothing in the universe is truly constant. Even the stars above you are moving, their patterns shifting so slowly that you can only see it across the span of centuries. And far deeper than those gentle motions, there are changes that run on a timescale so vast, you might never know they were happening until they were already complete. If the great black holes, the sleeping beasts at the hearts of galaxies, were to wake in large numbers, the change would not come as an explosion. It would come as a quiet transformation. A single quasar can alter the fate of its galaxy. flooding it with light, energy, and winds strong enough to sweep away the gas that makes new stars. Multiply this by thousands, tens of thousands, and you can begin to imagine the effect of a galaxy cluster filled with awakened giants. In some places, starbirth might bloom briefly, fed by the compression of gas at the edges of a black hole's influence. Entire regions could ignite with new suns, their blue-white light spilling across the spiral arms. But this would be temporary. The same forces that compress gas can also disperse it, leaving the galaxy without the raw material for future stars, and then the quiet would deepen. Not the peaceful quiet of a sleeping universe, but the stillness that follows when creation slows, when the birth of stars falters. Galaxies would begin to fade, their young stars dying without replacement. If enough giants woke at once, the balance of the cosmos could tip. It would not be a single moment of catastrophe. It would be more like a long tide, slowly pulling the brightness from the sky. You would not feel it from one night to the next. But over millions of years, the constellations would thin. The great arcs of the Milky Way would dim. The spaces between galaxies would grow darker still. The effect could spread far beyond their own galaxies. Outbursts from massive black holes send energy and matter deep into intergalactic space. Winds and jets can cross millions of light years, heating the thin gas that lies between clusters. This heat lingers, preventing the gas from cooling enough to collapse into new galaxies. In this way, the waking of the beasts in one part of the universe can starve the formation of stars in another, far-off place. The cosmos is connected more deeply than it appears, each part influencing the others through the long reach of gravity and energy. Even without direct destruction, the night could still be undone. Imagine looking up to find fewer and fewer stars each generation, until, one day, the familiar map is gone. Not because the stars have moved, but because they have died. And nothing new has taken their place. The danger is not in the violence, but in the hunger. Black holes do not merely consume. They change the flow of energy and matter around them. An entire galaxy can be reshaped by their feeding. They can decide whether it remains fertile with starbirth or becomes barren, and yet, the slowness of it makes it almost invisible. On the scale of human lives, the stars will always be there. The danger only reveals itself when you step back far enough to see whole galactic histories. Then you can see the eras of light and the eras of fading. The universe has known both before. In its youth, it was crowded with active black holes, their quasars blazing in every direction. Starbirth was rapid, galaxies were restless. Then, as the beasts quieted, a calmer age began. Now, most galaxies are in this quieter phase, their central black holes feeding only rarely. But there is no rule that says this must last. If a wave of awakenings began, perhaps triggered by a surge of mergers in the cosmic web, the sky could shift again toward that earlier, more violent age. It would be beautiful in its way. A universe full of blazing cores, jets of plasma threading the dark, the light of quasars competing with the light of galaxies themselves. But beauty can still be an ending, because that beauty would not last. The light would burn through the galaxy's reserves, and when it faded, there would be less left than before. The galaxies that fed their giants most fiercely would be the first to dim. The ones that resisted might last longer, but the spread of heat and energy would reach them eventually. In the end, the danger is not that the beasts wake forever, it is that they wake in unison. When they stir alone, the universe can absorb the change. A single galaxy flares, then fades, while others remain fertile. But when too many awaken, the balance shifts. The places where new stars can form become fewer. The light of the cosmos begins to thin. From a human perspective, such a transformation feels almost abstract. It takes millions, even billions of years. But to the universe, this is the work of a season, a cycle of growth and rest, light and darkness. And perhaps that is the truth you are meant to remember. The sky is not fixed. It breathes, it changes. It can give more light than you can imagine, and it can take it away if the beasts wake together. The night sky, you know, could be only a phase, a temporary arrangement in the long history of the cosmos. Someday, another pattern will take its place. You will not see it happen, but the quiet possibility of it rests above you, written into the hearts of every galaxy. There is a rhythm to everything, not the kind you hear in sound, but the kind you feel in the slow unfolding of time. A breath drawn in and then released. A tide that swells and then retreats. A heartbeat, steady and patient. The universe has its own version of this rhythm. It is not measured in seconds or minutes, but in millions of years, the slow pulse of creation and change. One moment in that rhythm is filled with violence and light, stars forming, galaxies colliding, black holes feeding. The next is a long stillness, when those forces rest and the cosmos seems to pause. You are in one of those pauses now. Most of the great beasts, the black holes that can remake. Galaxies are sleeping. Their quasars are dark, their jets silent. The heat and turbulence they once unleashed are fading, leaving space to cool, leaving the galaxies to drift in quieter currents. It is tempting to call this an ending, to see the dimming of activity as the closing of a chapter. But the quiet is not the final word, it is only the breath between them. In this calm, the galaxies regain balance. Gas that had been pushed aside drifts inward again. In some places, it begins to gather into clouds dense enough to ignite new stars. Whole clusters of suns prepared to be born, not in a rush, but in a slow, careful arrangement that can last for billions of years. The stillness is not empty. It is full of small movements, the quiet shifting of matter, the faint glow of stars too far away to see, the invisible passing of light from one side of the universe to the other. Even the black holes themselves are not truly asleep. They are waiting, turning slowly in the darkness, their gravity always at work. They pull gently at nearby stars, sip at faint streams of gas. The appetite is still there, only hushed. It is in this in-between state that the universe feels most at peace. There is no urgent rearranging of galaxies, no sudden surge of radiation to heat the cosmic seas. The fabric of space lies smooth, except for the slow ripples left from earlier motions. You might think this quiet will last forever, but history says otherwise. The universe's rhythm always returns. The giants will wake again, perhaps not all at once, but in waves. A galaxy here, a cluster there, each flare sending echoes across space dot between those moments. The quiet does something important. It gives the universe time to heal. Gas cools enough to settle. New gravitational bonds form. Even the faintest dust drifting in the dark has a chance to join something larger. The stillness is when seeds are planted for the next cycle of creation. There is a beauty in knowing that nothing is wasted. Even the absence of motion serves a purpose. The spaces between events shape the events themselves, just as the silence between notes shapes a song. The calm is also a gift to observers. In the frenzy of activity, the cosmos is loud, not in sound, but in the flood of energy, in the glare of light, in the quiet. You can see further, deeper. The dim galaxies at the edge of vision come into focus. Ancient light, long buried under brighter beacons, has a chance to be seen. This is the universe in a listening state. It waits just as you wait. For what, you cannot say, the next collision, the next awakening, the next great reshaping of the cosmic web. But the waiting is not impatient. It is patient in the way that mountains are patient, in the way that oceans are patient. And so you drift here, in the soft stillness between heartbeats. The pulse is faint but steady, the pause long but not endless. You are small inside it, but you are part of it, carried in the same rhythm that moves the galaxies. If you could stretch your awareness across eons, you would see it more clearly. You would watch the last quasar fade, feel the cooling of intergalactic gas, sense the faint tug of new structures beginning to form. Then, slowly, you would see the first signs of motion return, a stream of matter falling inward, a flare of light at the core of a distant galaxy, the first beat of the next pulse. The universe breathes. It breathes in the light and heat of its awakenings, and it breathes out into the stillness of its rests. Both are necessary. Both are part of its life. To be here now, in the quiet, is to be standing between two immensities, the echo of the last heartbeat, and the promise of the there is a limit to how many lights can burn at once. Stars are not endless. They are born from clouds. They shine, they fade, and they die. The universe has been making them for billions of years, but one day it will stop. Not all at once. The process is slow, drawn out over time, so vast it feels like eternity. Gas. Clouds will run dry. Starbirth will slow to a trickle. The last bright nurseries will empty. And when the lights go out, what remains will be the giants. These giants will not be stars, but black holes, the most massive, the most patient, the most enduring objects the cosmos has ever made, born from the collapse of stars and the mergers of galaxies. They will survive far beyond everything else. Even when the night sky is stripped of its constellations, they will still be there. You can picture them in that far future, not glowing, not feeding in dazzling bursts, but sitting in the great darkness, invisible except for the way they shape everything around them. They will not need to move quickly. They will not need to shine. Their presence alone will be enough to command the space they inhabit. By then, the universe will be quieter than you can imagine. The soft hum of starlight will be gone. The glow of galaxies will have faded to embers. Only the occasional whisper of radiation will mark the passing of time, and yet the giants will wait, not for anything in particular, just as they have always waited. They are not impatient. They have no sense of loss. They simply are. In that age, even the black holes will change. They will not grow as they once did, for there will be little left to feed them. They will shrink, very slowly, giving up tiny amounts of energy over unthinkable spans of time. This evaporation is not sudden or dramatic. It is the final breath of something that has held itself together for longer than stars, longer than galaxies, longer than memory. But until that moment comes, the last giant will remain. Perhaps it will sit at the heart of what was once a galaxy, though the galaxy will have long since faded into the dark. Perhaps it will drift alone, carrying with it the faint gravitational memory of the stars it once commanded. It will be the last anchor in a universe without a map, a single, silent weight, in a sea that has stretched itself too far to remember its shape. The universe by then will be strange in ways you can only just begin to imagine. Distances will have grown so great that what little light still travels will never reach anywhere else. Space will have expanded into a vast, cold emptiness where each surviving object is alone, and yet, even here, the pulse will remain, not in the beating of a heart, but in the steady, inevitable passing of time. The last giant will mark that time simply by existing. If you could be there, if you could sit in that darkened place, your awareness beside it, you would not hear anything, you would not see anything, but you would feel the pull. It would be the last sign that the universe still remembers how to hold something close. The last giant will not mourn the stars. It will not wish for the galaxies to return. Its existence is not tied to what came before. It belongs equally to what comes after. In its quiet, there is still connection. Particles may still drift past, ghosts from an earlier age, and when they do, the giant will take them in. Each one will spiral down, crossing the invisible edge, gone from the visible universe, but not gone from reality. It is here, in this stillness, that you begin to realize something, even in its most empty. The universe is not without presence. It does not need to be filled with light. To be alive, the last giant is proof of that. There will be no one to see it, no civilizations left to give it a name, no astronomers to measure its mass or chart its horizon. And yet it will exist as fully as anything ever has, for as long as it remains. The universe will still be holding onto a part of itself. It will still have weight. It will still have a center. Even if that center drifts in endless dark, when the time finally comes, the last giant will not collapse further. It will fade. Its mass will turn into a slow rain of particles. Vanishing into the sea of space, its horizon will shrink, fold inward, and dissolve. The last anchor will lift, and the universe will have no more giants. What follows is difficult to imagine. A universe without structure, without weight, without the slow turning of gravitational tides. A place where there is nothing to orbit, nothing to fall toward, nothing to hold, and yet, even then, the pulse will not be entirely gone. It will simply be different, spread thin, carried in the drift of what remains. You are part of that pulse now, and you will be part of it then, even if not in a form you would recognize. The matter that makes you, the energy that flows through you, will still be part of the universe's breath. The last giant will not remember you, but you will have been shaped by the same rhythm. You and it are both temporary shapes in a much older pattern. There is something comforting in that thought. Even in the end, you are not separate from the whole. You are carried in the same long tide that will one day carry the last giant away in that final age. There will be no dawns, no nights, no seasons, only the steady deepening of the dark. But as long as the last giant remains, the universe will not be entirely still. Its gravity will keep the idea of movement alive, and when it is gone, that idea will still be here, not in the pull of masses, but in the quiet memory of what once was. And so the universe will go on, not in light, not in weight, but in the faint echo of its own heartbeat, one you are still part of, even when the last giant has long since faded at ext. It is not forever, but it is enough.